In this video, we're going to be talking about chain rule. Dun dun dun. Yeah, chain rule is one of the hardest things to learn firstly when you're doing derivatives. But genuinely, as long as you have a lot of practice with it, it's not even that bad. So let's show you the derivative of some function inside of a function. So what do I mean by function inside of a function? Well, if you had, let's say, sine of 3x, your entire function would be your sine function, correct? You can take the derivative of sine relatively easy. But g of x would be the function inside of the function. So g of x would be your 3x in this case, for this example. Now you're not always going to have, the only example isn't sine functions. There could be other types of functions inside of functions, like e to the 2x. The total function is e to the something. And the little function on the inside is g to the x, which is 2x here. So chain rule basically states that if you want to take the derivative of a function inside of a function, you must multiply the derivative of the inner function by the derivative of the outer function. So what do I mean by this? Well, if we follow this format, we basically say that sine of x right here is the full function. So what's a derivative of sine of something? Right, the derivative of sine of, let's use u in this case for a variable. The derivative of sine of u is cosine of u. Correct? So the derivative of your outer function, f prime, in our case, is equal to cosine of, well, our function stays inside, so cosine of 3x. So cosine of g of x, which is 3 of x in this case. But chain rule states that we need to multiply this function by the derivative of g of x. So g of x is just 3x. And the derivative of 3x using power rule is just 3. Therefore, our derivative for sine 3x is 3 cosine of x. Now, if you just wrote down cosine of 3x, this would be wrong. If you just wrote down cosine of 3x, this would be wrong because of chain rule. So it generally just takes a lot of practice, because sometimes you're not only going to get one chain, you're going to get 5 chains even. You could get 3 chains, you can get 4 chains. It's not only one chain where you're not only going to have a function inside of a function, you can have a function inside of a function inside of a function. That might scare you a little bit, but chain rule is genuinely not that bad. You just need, a lot of people just need some practice with it. So if I wanted to give you another example of chain rule, we'll have, let's use e to the 2x in this case. So e to the 2x, the entire function, the big guy in this case, is f of x, correct? And we'll treat this as e to the u. And the little function on the inside of your function is g of x, which is 2x in this case. So if e to the u, and u in this case is g of x, was e to the 2x, then this is sort of the format of it. You have a function gx, which is 2x in this case, inside of a larger function, which is e to the x, or e to the u. So you plug in 2x into e to the x up here to get e to the 2x. So how do you solve for this derivative? Well, this derivative, well, using chain rule, you find that derivative of your large function, the derivative of e to the anything, right? The derivative of e to the anything is simply the same thing. So e to the anything is just equal to e to the same thing, right? But we need to use chain rule. So in order to use chain rule, we need to find the derivative of g prime. Not the derivative of g prime, the derivative of g. The derivative of g, well, if g is 2x, then the derivative of g is 2. All right, using power rule. So the derivative of 2e to the 2x is equal to, the derivative of e to the 2x is equal to 2e to the 2x. So chain rule, again, always, as always, like anything in math, requires a good bit of practice. That's why we're going to do some problems right now. So for this problem, you have x squared plus 4 squared. Now you could just distribute the square, right, by multiplying x squared plus 4 with itself, and then just using FOIL and then using power rule. But you can use chain rule in this case as well. And chain rule, once you get used to it, is significantly easier than just doing that. You'll save a lot of time in your tests. And not all functions you can do the distributing thing as well. So some functions you need to use chain rule, but in this case you could have distributed, but I'm going to show you the chain rule example for this. So what is the larger function, right? What is the function f, and there's a function g inside of f. Well, the larger function in this case, if I were to make some more space on the upper end, is x squared plus 4 squared, right? So the larger function is just something being squared, right? And we can replace this something with u. So u is your inner function. U essentially is equal to g to the x. But we're just going to replace it with u, since the larger function is basically just something being squared. So how about the inner function? Well, the inner function is g to the x. And g to x is equal to x squared plus 4. So remember, g to the x is equal to u. But u is just a representation of what of g to the x in total, what's happening to g to the x in the larger function f. So now that we have these two things differentiated, we can solve for this using chain rule. Well, let's find the derivative of g to the x. So the derivative of g to the x is just, well, the inner function, which is x squared plus 4. The derivative of this is 2x. All right, what about the derivative of f? Well, the derivative of f is just something being squared. So what do you do with something being squared? Well, you just use chain rule. So the derivative of u squared is 2u. What we can do is distribute the 2 into here. So we get 4x times u, but u is equal to g of x. So we can just replace u with x squared plus 4. And the derivative of your function x squared plus 4 squared is equal to 4x x squared plus 4. Now keep in mind, this u thing would be very, very helpful. It can help you do this step by step more than just having some instinct behind it. So it's sort of like a crutch. You can replace your g of x with the function u temporarily until at the end of the problem. So these are one of the cases where you're not going to be able to use a power rule. You're going to have to use chain rule. So we have the function e to the 3x squared plus 5x minus 1. So what are the inner and outer functions in this case? Go ahead and take a guess before I say it. But basically the outer function, let's use red. The outer function is simply e to the 3x squared plus 5x minus 1. So that's e to the something, right? U in this case. That's equal to our larger function, f of x. Our inner function is what's actually being powered, which is g of x. And g of x is equal to 3x squared plus 5x minus 1. So there's a function, right? There's a function, g of x, inside of a larger function, e to the u in this case. Remember, u is a substitute for g to the x to help us as a crutch to solve this problem. So what do? Well, we need to find the derivative of g. So the derivative of g is 6x plus 5, right, using some power rule. Don't forget the parentheses. And the derivative of e to the u is just itself, e to the u. But remember, at the end, we need to replace u, as u is just as a guide for us. So e to the u is equal to e to the g of x, since u is equal to g of x. So we just replace e to the x with g again, the function g. So we get 3x squared plus 5x minus 1. Therefore, our total answer, let's use a different color. Therefore, our total answer is this guy right here. And as you can tell, all I did was take the derivative of e and then put the derivative of the inner function and just multiply it by your larger function. Let's go ahead and use the chain rule for natural logarithm of 7x squared plus 1. So again, we need to differentiate the outer function and the inner function. So let's go ahead and write the outer function. Well, the outer function is natural logarithm of something. Now you're not always going to get parentheses for the outer function. That kind of guides you a little bit, but in a lot of cases you can think of the outer function as something that has parentheses inside of it, like sine of something, right? The outer function is sine in this case of some function u for sine. But the outer function is natural logarithm in this case. So ln of just something, right? U in this case. And remember, u is the outer function, right? U is the, inner function. So u is g of x in this case. And then g of x is the inner function, which is 7x squared plus 1. So the inner function inside the outer function is the relationship of chain rule. So let's go ahead and do this problem. Derivative of g prime is 14x, power rule. And then the derivative of f prime is, well, the derivative of ln is 1 over u, correct? The derivative of ln u is just 1 over u. But we must replace u in the end. So we have 14x over, let's draw the 4 better. So we have 14x over 7x squared plus 1. And this right here is our answer. So what I did was just simply replace u with g of x. So I just put the g of x on the bottom portion of this fraction and then multiplied 14 of x at the top into the top of the fraction. So now this is what I mean by e to the cosine of x cubed. This is what I mean by chain rules inside of chain rules. Poor you guys. Very, very poor you guys. You're going to have chain rules inside of chain rules. So how do you solve for this guy? Well, remember, the essential idea of a chain rule is that there's an outer function, inner function. So let's differentiate the outermost function first. So the outermost function in this case is e to the something. Correct? It's just e to the something. This was in parentheses. So e to the something is the outermost function, which is f of x in this case. And the inner function is for e. So the inner function for e to the u is g of x, which is cosine of x cubed. But I guess you can already tell where I'm going with this, because x cubed inside of your cosine function is also inner function. This guy right here in itself is an inner function, but we'll deal with that later. Let's go ahead and solve these first. So u is equal to g of x. Always remember that. Now we need to solve for the derivative of g prime. So derivative of g prime is, oh, now this is where we get into another chain rule. So derivative of g prime in itself, so g in itself has a function inside of a function. So g, let's use different numbers, let's use different letters, let's use a b, c, d, e, f, g, h, I, let's use function h and k, alright, since those are nice looking numbers. So function h is your outer function in this case, which is cosine of something. Alright, let's not use u, let's use a cosine of v. No, v looks like a bad number. Z, cosine of z. Okay, this is cosine of something, z. Okay, and what's that something? Well, that something is your inner function, which is g of x, no, k of x in this case. So k of x is analogous to g, and h is analogous to f for the inner chain rule, but I just wanted to use different letters. So k of x is the inner function, so the inner function is equal to x cubed. Okay, now we can take the derivative of g. So the derivative of g, so g was a function cosine of x to the power of 3, correct? So we need to take the derivative of the inner function for cosine. So the derivative of the inner function is, well, the inner function is x to the power of 3, so x to the power of 3 derivative is 3x squared. Okay, now we take the derivative of the outer function for g. So we take the derivative of the outer function, and in this case the outer function is cosine of something. So cosine of z's outer function. So the derivative of cosine is negative sine of u, of z in this case. But z is equivalent to k here. So z is equal to your function of k. So we'll replace z with x to the power of 3. Alright, now we have the derivative for g. So this was a chain rule inside of a chain rule. This is simply your derivative for g of x prime. Now we take the derivative of your outer function f, which is e to the u basically. F is just e to the u. So e to the u is just e to the u. But remember, u is equal to g of x, so we can replace u with g, which is cosine x to the power of 3. So this was a chain rule inside of a chain rule. And maybe it'd be easier if you just took this function out of the way and used, if you just didn't put it along with the problem. But the idea of chain rule inside of a chain rule is that, well, you can have multiple functions. You can have functions inside of functions inside of functions. And in doing so, you have to use chain rule multiple times. Now, right now, the way I'm explaining is just super step by step. But eventually, you'll get down to intuition. So you don't really need to write down all these confusing letters on the screen. But the confusing letters are sort of a map for you guys in order to solve this. So again, we have a chain rule inside of a chain rule. And a lot of math teachers have very corny names for things, but they call an intuition for chain rule, they call it chain rule eyes. So hopefully you guys can develop that. It's simply just a lot of pattern recognition. But this one again is a function inside of function inside of a function. So let's differentiate the outer function. So the outer function is just the natural log of something, u. All right, it's just the natural log of something. All right, that's why, hence the parentheses. And the inner function is the sine of something, 3x squared in this case, which is g of x in our formula. And the outer function is f of x. So first thing we need to do, let's find the derivative of g of x. So the derivative of g of x is the derivative of sine. So the derivative of sine 3x squared. Now, for the derivative of sine of 3x squared, we have to use chain rule again. So we need to differentiate an outer function. The outer function in this case is sine of u. And then the derivative, the inner function in this case is g of x, which is 3x squared. Okay, now we can take the derivative of sine of x, knowing that we differentiated these. So u is equal to g of x. So we take the derivative of g prime on this inner function. The derivative of g prime is the derivative of 3x squared, which is just 6x. And then your derivative of f is the derivative of the entire function, which is sine of something. So the derivative of sine of something is just cosine. But u, again, we always have to replace u, so let's replace u with g prime, with g of x, which is what u is equal to. So u is equal to g of x, so we replace cosine of u with g of x right here. All right, now we have the derivative for g. This is the derivative for the previous g, so the larger function's g. So we can write this down here, 6x cosine of 3x squared. Okay, now we find the derivative of the outer function for the larger guy right here. So the derivative of f is ln, right? ln is f, so the derivative of natural logarithm is 1 over u. But what is u? Well, u is, again, u is equal to g of x, so we can replace this guy right down here. So we get 1 over the sine of 3x squared. And if we want to put this inside of our function, we get 6x cosine 3x squared over sine of 3x squared. But again, if you want to simplify this, you just get 6x cotangent of 3x squared. Right? Cosine over sine is cotangent, so we can simplify this into cotangent.